So in the last part we saw that the COCOMO model has three types: basic model, intermediate model, and you have the detailed model. So first we will see the basic COCOMO model. There are three types: basic, intermediate, and the detailed. So we will see what? First we will see the basic model completely. So basic COCOMO model. The basic COCOMO model provides an accurate size of project parameters. The following expression give the basic COCOMO estimation model. Effort is equal to A1 star kilog, A2 PM is what? Person month. TDE, that is your development time, is equal to B1 into effort, B2 that is months, where kilog is the estimated size of the software product initiate in the kilo lines of code. A1, A2, B1, B2 are the constants of each group of software product. TDEV is the estimated time to develop the software expressed in months, and effort is the total effort required to develop the software expressed in person months. That is your PM. Estimation of the developed effort. For the three classes of software products, the formula as. So we saw that A and B are what? A and B are constants, and they will depend on the types of the development, on the types of the software products or the classes. So organic effort is equal to 2.4 kilog into 1.05 pm. So this formulas you have to remember. Semi-detached effort is 3 into kilog into 1.12 pm. Embedded is effort is equal to 3.6 kilog into 1.20. All these formulas have to be learned. So your 2.4, when you add it with 0.6, you get how much? 3. When you add 3 with 0.6, you get 3.6. So you have to remember 2.4, 0.6 you add, 3 you get, 0.6 you add, 3.6 you get. These, there is no shortcut for this, you have to remember this: 1.05, 1.12, 1.20. So this is the way I remember. By adding 0.6 and these values, I have learned them: 1.05, 1.12 and 1.20. Organic, semi-detached, and then you have embedded. Development timer. Formula for development time. First you have to remember, for organic, for semi-detached, embedded, for all the three it is 2.5, 2.5, 2.5. Into, you have to do what? Effort. Effort is again given in the question. You have to find that. How you find the effort? By the formulas above. By these formulas. Into, you have 0.38, 0.35 and 0.32. So what are you doing? How is this pattern going? 0.38 minus 0.03, you get 0.35 minus 0.03, you get 0.32. So I have remembered it this way, that I am subtracting 0.03 when I am going from organic to semi-detached to embedded. So this is the way you can also remember the formulas, but you have to remember the formulas for development effort as well as development time. Now let's see the example. Suppose the project was estimated to be 400 kilog. Calculate the effort and development time for each of the three models, that is organic, semi-detached and embedded. So for organic, we know the formula is 2.4 into whatever effort your kilog is given, that is 400 into 1.05. That is for your organic. For semi-detached, we know it is add 0.6. So that is giving you 3.6 into 400. Into this you have to remember 1.12. For embedded, you have 3.6 and 0.6 into 400 kilog. Into this you have to remember 1.20. For this is your formulas for calculation of efforts. Once you get effort, how will you find development time? For organic, it will be 2.5 into effort for organic is 129.5.31 into 0.38. That is your development time. Again over here 2.5 into effort, whatever you got, into 0.35. Here also you will do the same. 2.5 into effort is 4772.81 into 0.32. Whatever you get, that is your what? That is your development time. Next example, a project size of 200 kilo is developed. Software development team has an average experience on similar type of projects. The project schedule is not very tight. Calculate the effort, development time, average staff size and productivity of this project. So when you give like this, when they say it is average, we have to assume that it is semi-detached mode. The semi-detached mode is the most appropriate mode, keeping in view the size, schedule and experience of development time. Hence, we say that effort is equal to 3.0 for semi-detached into 200 kilo into 1.12. We get effort as 1133.12 pm. And your TDEV is 2.5 into effort, that is 1133.12 into 0.35, that is 29.3 pm. So average staff size is what? E by D. E is your effort upon D is your development time. So this much persons is your average staff size. Productivity is kilog upon effort. Kilog is given to you as 200 upon effort. We found out as 1133.12. So you get the kilog. Kilog you have to convert it into log. So that is 176.5. We wrote it as 176. You have to multiply this by 1000. 176.5. We wrote that as approximately 176. You can write it as 177 also, but we write it as 176. Why? Because whenever 5 is there and there is an even number, we always keep it as it is. Whenever it is an odd number, we will give. So if it is 176.5, we will write it as 176. If it is 177.5, that means this is odd, right? So whenever it is odd, you convert it as 178. Whenever it is even, 0.5, for 0.5 only this rule is applicable, okay? That time leave it as it is. So that is why we left it as it is as 176 log per MP. This is what is the questions on basic COCOMO model. You have to remember the formulas. Again I say this.